On our second lesson, we're going to talk about angles a little bit more, and we touched on this in our first lesson, but today we're going to take it a little bit further and go into a little bit more detail on it. So as we learned in our last lesson, an angle is really just two rays that share an endpoint. And I can name it using any of the three letters. I have to go in order around my angle though. So if my point A is here, B is my vertex, and then C, I have to go angle A to B, turn, go, and C. Or I can go the other way. I can start at C, go to vertex B, turn, go to A. I can't go B, A, and then C because that would be a different angle. I can also use a number to name an angle if that number is in my picture. If I'm working on a piece of paper, I can write it in my picture. If I'm working on a PDF that I'm going to turn in, I can write it there as well. If I'm working on something that isn't one of those two and I can't add it to my picture, then I'm going to choose to use letters. And I also can use just the vertex letter if there's only one angle B. So in this picture, there's only one angle B. If I had a situation where I had multiple angles coming from the same vertex, I couldn't call this angle X because there's three different angles I could be talking about. So in this case, I would have to use three letters or add some numbers in to clarify which one I'm talking about. My angle bisector is going to split an angle into two congruent angles, so two angles that are the exact same size. So if I have an angle like this, my angle bisector is that red line coming through and splitting that angle. And the way that I show that the parts are congruent is with little baby arches. If I had multiple, so if I had another angle with an angle bisector and I wanted to show that these were also congruent, I can either use two little arches or I can start using tick marks on them. So I could do something like that. All of those mean that, hey, like this guy's congruent to that guy, and these two are congruent but not the same measure as that other one. And hey, here's a third angle measure congruent to that piece. The vertex is just that shared endpoint, so when I'm looking at my angle, this is my vertex. We usually say that our legs are then the sides of the angle, so the red part would be called a leg. We're going to do some examples, and we're going to name them in four ways. Quick note, we're only using one letter if there's only one angle at that vertex. So when I look at this, I've got angle QRS is one option. I can reverse that and do SRQ. I can also do angle 2, and I can do angle R. On this next piece, I'm starting at D, go to my vertex E, turn, go to F, angle D, E, F. I can reverse that, angle F, E, D. I could use the number that's written for, or because there's only one angle E, I could do angle E. And then I've got this one as well. I've got angle I, J, K. I can reverse that, K, J, I. I could do angle 3, and I can do angle J. The measure of an angle is going to be the smallest amount of rotation about the vertex from one ray to another. Whoa. Here's what that means. I want to know what rotation to get from here to there out of 360 degrees. We never measured this part of it. That's called the reflex angle, and we don't need that. So you're always going the shortest route there. There will be another video about drawing and measuring angles using a protractor, so definitely look for that. But to classify my angle, if it's less than 90 degrees, I say it's acute. Baby animals are cute. Half of Clementine's appeal is that she is little, so she is cute. Obtuse is always greater than 90 degrees, and right is exactly 90 degrees. When I've got a 90-degree angle, I show it's 90 degrees by putting the little square in the corner. I'm going to use congruent for the actual angles. So I can say angle ABC is congruent to angle DEF, But if I'm talking about their measures, I add a little m out in front, and I read this as the measure of angle ABC. That would equal the measure of angle DEF because the angles themselves are congruent. So I'm still only using equal with numbers, values, magnitudes, and congruent with objects. Just a quick